Okay, so I didn't really do any videos on graphing because I wasn't able to do that on whiteboard at home. But now that I've learned I can record straight from the smart notebook tool, I can go ahead and put one up. And a lot of people are still struggling, so hopefully this will help with the graphing. So the first thing, look down here, you see these two equations. They are in the format where y is all by itself. Right? And then we have the x and the constant term on the other side of the equation. This graphing technique only works with these types of equations. Again, y is all by itself, and the x and the constant term, if there is a constant term, it could just be x, which means the constant term is really 0. But basically, y is all by itself, x is on the other side. And then maybe there's a constant term, maybe there's a number. Constant term just means a number, no variable. So I'm going to follow at least the chart paper that is up in the room. It's in the blue ink. It's for graphing when we're using slope-intercept form. That's what this is called. I'm actually doing a system of equations. So I have two equations that I'm going to graph. And wherever the two lines connect, if they connect, that would be the solution. If one line is right on top of the other line, then that would mean it's an infinite number of solutions because they're touching at every single point. So my first step, I need to find the y-intercept for each of these equations. I'm going to kind of do them both at the same time. So my y-intercept is always the term that doesn't have x in it. So that's my y-intercept for that particular equation. Gotta change my pin. I don't want to do that though. Let's try doing this. Let's try changing it just 10. Is that going to get rid of it? Right, like that. There we go. All right, so let's try that again. So I start by locating the y-intercept with both of these equations. Again, it's the term that does not have the x with it. So it's just a number typically, unless they give you an equation with all variables. So those are the y-intercepts for each of those equations. So now our first step is we just plot that point on the y-axis. So again, the y-axis is this entire line. That's the y-axis. The y-intercept is just this number on the y-axis. So for example, for -3, for the y-intercept for this equation, I go to the y-axis and I find -3. And I just put a dot.
According to math is fun. Y-axis, or
Right
the
there.
line on the graph that runs vertically through 0. It is used as a reference line so you can measure from it. See coordinates.
Right. So I plotted the y-intercept for the first equation. Now I'm going to go ahead and again, I'm going to plot the y-intercept for the second equation. So this +2. Again, this is the y-intercept for the second equation. I'm going to go ahead and plot it right now, right here. Make it a little bit bigger because the green doesn't stand out quite as much, it looks like. All right, so that's the y-intercept for the second equation, which is in green. So here, it's going to get a little tougher to use my drawing tool, so I'm going to try to use my finger and see if that works. So next, we need to know, I'm going to go back to the first equation. It's the one with the red -3. I know that red dot, that red ordered pair, which is 0, -3. I'm going to write that. So that red ordered pair right there is 0, -3. I know that ordered pair is going to be on the line. Now all I have to do, because it's the y-intercept, by definition it's on the line, all I need to do is say, okay, where do I go from that line to create one more point so that I can draw the line? Then I would just connect the 2 points. So I see that the rate of change or the slope is this positive 2, where it says 2x. The rate of change is the 2. It's not 2x, it's just the 2. Again, that poster is up, it points straight to the M. That's the rate of change. So I say, okay, well, that first of all means I'm going to have a positive slope. So I know my line should be sloping up from left to right. Now I just have to figure out exactly where it's going. So I take that 2 and I make it into a fraction. I'll just bring it over 1. If it was already a fraction, I wouldn't need to do anything. The top number is going to become my rise. The bottom number is going to become my run. Change that R a little bit. So my rise, and then the bottom number is my run. So rise means up and down. So that means I need to start from my red dot, because again, I know that red dot is on my line, because it's the y-intercept. So from that red dot, I need to either go up or down 2. Well, it's positive 2, so I need to go up 2. So I'm going to go from this dot right here, up 1, up 2, and then from there, I'm going to look at the bottom number, the 1, which is my run. Run means left and right. It's a positive 1, so I need to go to the right, and that's where I put the dot. It does not mean that I go from -3 to +2. People are still just putting a dot over here on +2 and then connecting the 2 dots. It has nothing to do with that. You go from this point up 2 because it's positive, and then right 1 because it's positive. So up 2, right 1, and then I put my next dot there. For some reason it made it green. Well, we can fix that. There. Close enough. So now I have 2 dots, or 2 ordered pairs, technically, 2 points. Once you have 2 points, you can create a line. So I'm just going to create a line from here through that. And it would have arrows on both ends. I can go ahead and make it have arrows on both ends, I guess. So let's... No, that didn't work. Or did it work? Did it work? Oh, let's try it. So it's got an arrow on one end and an arrow on the other end. Probably won't be real big arrows, but you'll get the picture. Stop it. Not sure why it's not. Oh, didn't actually. Let's try that again. Just a little bit of time. Right click. Properties. Let's try that again. I don't know if this is going to work either. Okay, so they're teeny tiny arrows, but you can see it has arrows on it. So that would be my first. Oh, and one thing I also want to do is I'll change that to red because that was my red line. All right, there we go. So there's my red line. The line would go on forever, all the way up. I might have to extend it in a second. We'll see. Actually, no. All right, so now from this point right here, so now I'm going to the second equation. I'm going to graph the second line. Okay, well, I've already plotted my y-intercept. That's the +2. I now need to do the same thing. I'm going to erase what I did before. If you need to see it, you can rewind the video, go backwards. I need to do all of it all over, even that rise and run. So I need to take this -3. So again, now -3 is my rate of change for the second equation, because it's next to the x. Whatever value is next to the x, that's the rate of change. So -3. I'm going to put that over 1. It's easier to do it in the small part. And now again, actually, I'm going to do a finger if this works. That is my rise over my run. So rise, once again, rise means up or down. If it's a positive number, you go up. If it's a negative number, you go down. So in this case, I have a -3. So I'm going to start at my y-intercept, and I'm going to go down 3, so down 1, 2, 3. Again, it does not mean I go from this over to -3. It has nothing to do with the number on the axis as far as the rate of change and where you go. The only thing that has to do with the axis are these numbers, the y-intercepts. So from here, I go down 1, 2, 3, and then I go over +1, because that's the bottom number is +1. So down 3, right 1, and if you'll notice, it actually hits in the same point that my other line hit when I moved. So now I just create a line from that, and I just say, okay, well, I'm going to go through both of those points. This line a little bit longer. And now I've created the second line. It's already got the arrows on it, which is good. So now I just need to change the color of the green. And now I've drawn both lines. As I said, if you'll notice, where they cross is going to be the solution, and they cross right there at -1. I'm sorry, 1, because the x value comes first, so 1, and then -1. So this point over here, by the way, was 0, 2. So write that in. So this point over here was 0, +2. That was the y-intercept for the other line. And then the point that works as the solution is this point right here, where they cross, and where they cross is 1, -1. So that means that 1, -1 is on both lines, because that's where they cross, which means it works for both solutions. So if I were to plug in 1, -1 into both equations, it should make both equations true. So I'm going to go ahead and do that just to prove it to you. So for the first equation, x is +1, y is -1, so it should be -1 should equal 2 times +1, subtract 3. So 2 times +1 is 2, +2 subtract 3. Sure enough, that is correct. It would be -1 on the left and -1 on the right. So now let me test the bottom equation. Once again, y is -1, and that should equal -3 times, we said x was +1, and then +2. So let's check it again. -1 on the left, -3 times +1 is -3. -3 plus 2 is -1. So it works for the second equation as well. So that's a quick lesson on both graphing from y, or I'm sorry, slope-intercept form, which means y is all by itself, and then also a quick lesson on when you graph two lines in a system of equations, the point where they meet is the solution to both lines. It's the one spot that works in both of the equations.